So we are going to do just kind of a chapter 2 wrap up today. Neither one of these is worth a whole video in themselves, but together, yeah. First of all, general dimensional analysis, not working with the metric units, with the metric system, just something you probably did in algebra, and then temperature conversions. We'll be doing temperature conversions more later on, and this is just the introduction. Okay, so let's look at a general dimensional analysis problem. We want to convert 1.25 centuries to minutes. Okay, now there's no direct way to do that. I suppose you could maybe look it up on your phone and they would do it for you, but suppose you couldn't do that. Suppose all you have is a calculator. So you would probably go from centuries to years, to days, to hours, and then to minutes. I don't think we would use months in here, years and months and days, because months vary. So this would be the most reproducible way of doing it. You guys all know how many years are in a century, how many days are in a year, assuming it's not a leap year, how many hours are in a single day, and how many minutes are in an hour. So I'm just going to do the conversion factors. We don't have to go through the equalities because you know them already. So we're going to start with our 1.25 centuries. Remember, we can put that on top. It's always in the numerator, but if you want, you can put a 1 under it. And we need to convert that to years. Well, you know, and I know that there are 100 years. It's an integer, or we can put a decimal place after it. 100 years in 1 century. That's letting the centuries cancel. Okay, now we've got to convert to days, and there are 365 days in 1 year. It's really funny. I was in one of my college classes once, and somebody asked me how many days there were in a year. And I thought they didn't know, and they were just being overly concerned whether they should use 365 and a quarter or 366, if they should take that extra day for leap year and put that into days in a year. But no, we're going to assume 365 days in a year. Okay, so the years have canceled. Now we're to units of days. Remember, every time you see an arrow, you've got to put a conversion factor in. So then we know that there are 24 hours in 1 day. Sometimes it would be nice if there were more. I'm not worried about sig figs here because these are all defined quantities. Days cancel, meaning they're integers. And we are at hours. If we stop there, we would know how many hours. And you know that there are 60 minutes in an hour. Okay, we have ones in the denominator, so while it's good to have them there because they cancel our units, you don't have to do anything with them numerically. So I'm just going to take 125 times 100 times 365 times 24 times 60, and since I was using my phone to do this, it did not give it to me in scientific notation, but it did give me 65,700,000 minutes, or 6.57 times 10 to the positive 7 minutes. How'd I do that so fast? I remembered that a million is 10 to the 6th. And it was just one more than that. Okay, so you're going to have some problems like that on the test. Not that long, but you guys know how to do things like this, I hope. Next is temperature conversions. We are only going to do Celsius, if I spelled that right, to Kelvin, and the reverse. Yes, Celsius to Fahrenheit and Fahrenheit to Celsius is really useful if you're traveling, but we never do anything in Fahrenheit in science, so I'm just leaving that one out. There's a few in your homework problems. Do it. I always have to work out the relationship to do it myself. I've gotten so I rely on my phone. That's terrible. Okay, so to get from Celsius to Kelvin, I take degree C and I add 273 and that will give me kelvins. And if I want to go from kelvins to Celsius, I take kelvins, I subtract 273, and I get degrees Celsius. So let's do something fairly useful. Let's look at room temperature. Usually when your book says room temperature, they're assuming 25 degrees Celsius. Anytime we're dealing with gases, we have to switch to kelvins, so 25 degrees C plus 273 equals 298 Kelvin. That's it. Kelvins have no degrees. If I'm colder than that, negative 30 degrees C, and I add 273 to that, I end up with still a positive Kelvin, 243 Kelvin. Kelvins never go negative. That's why they're valuable, but we'll get into that in another chapter. So I was trying to think of something halfway useful for Kelvin to Celsius, except I didn't do the calculations for this yet. Okay, I'll do that in a minute.
Liquid nitrogen.
What?
Do liquid nitrogen.
LED lights, okay. They have different temperatures, especially if you have a ring light for selfies or whatever else. And if you're looking at 1,000 Kelvin, you're looking at a pretty red light. And if you're looking at 5,000 Kelvin, it's pretty much the middle of the spectrum, and it's kind of a white light. It's kind of normal. It's not a blue white. It's not a yellow white. It's just kind of white. So if I wanted to do that in Celsius, Roger, can you subtract for me in your head? If I have 1,000 Kelvin and I subtract 273 from that, I would get 737 Celsius. That is still awfully hot. If I have 5,000 Kelvin and I subtract 273, that would give me 437. No, 4,000. Roger, give me the number.
4737.
4737. Thank you. Degrees Celsius. My husband can do anything with numbers in his head, and I can't. That's the voice you hear. Okay, so those LED lights, if they were actually burning lights, like a halogen lamp or something, would be incredibly hot. Fortunately, they're LEDs, and they stay cool, but that was one of the more practical things I could think of to give you from Kelvin to Celsius. So remember these two equations, and we are done with chapter 2.